A warm welcome to all the students. In the second part of the S block elements, we are going to discuss the elements which are located in group 2 in the periodic table and are also famously known as alkaline earth metals. The group 2 elements consist of beryllium, magnesium, calcium, strontium, barium and radium. As we said, they are famously known as alkaline earth metals. The word metals because they are metallic in nature, alkaline because their oxides are alkaline in nature, and earth because their oxides are found in the earth. The alkaline earth metals are comparatively less reactive than the alkali earth metals, that is group 1 elements. Still, their reactivity is too high for them to occur in their free state in nature. Therefore, they are always found in combined state, generally as carbonate, sulfate, chloride, and silicate in the Earth's crust, and as chloride and sulfate in seawater. The alkali earth metals have 2 electrons in their outermost valence shell. Since 2 electrons are involved in metallic bonding as per the electron C model, which was suggested by Lorentz, the metallic bond forms are stronger as compared to those in alkali metals, because if you can recall, in alkali metals, single electron was present in their valence shell which participated in metallic bonding. Also, they are smaller in size from alkali metals, therefore this smaller size results in their closer packing in the metal lattice, increasing the bond strength. But this metal bond strength decreases as we move down the group from beryllium to radium because the size is increasing. Now let's have a look at some of the physical properties of alkaline earth metals. The first physical property that we are going to discuss is atomic radius. As we move down the group from beryllium to barium, we can see that the atomic radius, which is mentioned in terms of picometer, increases. This increase is due to the addition of an extra electron shell at each period. But they are smaller in size than the corresponding alkali metals because of the fact that a higher nuclear charge is pulling the same number of electron shells inwards. The next physical property is density. As we can see that as we move down the group from beryllium to radium, the density first decreases and then it increases. It does not follow a regular trend. Also, as compared to the corresponding alkali metals, the alkaline earth metals are denser and harder owing to their small size and closer packing in the crystal lattice. Melting and boiling points of the alkaline earth metals. They are low and do not follow a regular trend in the group, as we can see in this table. These are the values of the melting point expressed in terms of Kelvin, and these are the values of boiling points expressed in terms of Kelvin. However, they are higher than the corresponding alkali metals melting and boiling points due to closer packing and stronger metallic bonds in alkaline earth metals. Next physical property is heat of atomization. It is the change in enthalpy which occurs when 1 mole of a substance at 298 degree Kelvin and 1 atmospheric pressure is converted into its free atoms. Now, their value of heat of atomization is higher than the corresponding alkali metals because of the closer packing in their crystal lattice and stronger metallic bonds. However, as we can see that as we move down the group from beryllium to radium, the heat of atomization is decreasing gradually. This is because of the fact that the cohesive forces in their lattices decrease as there is an increase in size on moving down the group. Next property is ionization energy, which is the energy required in the removal of outermost electron from an isolated gaseous atom in its ground state. IE1 depicts the first ionization energy that is involved in the conversion of a neutral gaseous atom into a unipositive metal ion, And IE2, which depicts the second ionization energy, is the ionization energy corresponding to the conversion of a unipositive ion to a dipositive ion. The value of both IE1 and IE2 decrease as we move down the group because the atomic size as well as the ionic size decreases, and thus the attraction of the nucleus on the remaining electrons increases. The first ionization energy of alkaline earth metals are higher than those of the corresponding alkali metals because of their smaller size. And the second ionization energies, they are much lower than the corresponding alkali metals because the alkaline earth metals acquire noble gas configuration on losing 2 electrons. Therefore, they readily exhibit oxidation state +2.